A long time ago, there was this guy named Leonard Euler. You don't really need to know his name. I just really like to write and say his name. It looks like Euler, but his name is Euler. And he looked at this expression, which this might look familiar after yesterday's formula. Does this kind of look like the parentheses in the compound interest formula? So he looked at, what if we make that n number really, really big? So instead of compounding monthly, weekly, daily, what if we could compound the interest, 50 million times per day? So he started plugging in numbers for n that were huge, and he found that it approached the number 2.718. In fact, it approached the number 2.718288183, and it keeps on going and going and going and going. This number has been identified as the number e. E is kind of like pi. I think they used e because Euler found the number. But e is a number kind of like pi. You know how we typically say pi is like 3.14? E is approximately 2.72. It is called the natural base. It's related to the natural log, which we are going to get to in the second half of chapter 6. So first we're going to use e to simplify some expressions. And the nice thing is you can treat e just like it's any other letter. Treat e like it's an x, treat e like it was pi. So e to the third times e to the sixth. If it's multiplication, you add those exponents, that becomes e to the ninth. Number 2, 10e to the third divided by 2e. The 10 divided by 2 gives you 5. E cubed, divide one of those e's out, you're left with e squared. Number 3 is a little weird. Distribute that exponent, so that's 3 squared. And then for the e, we need to multiply the negative 4x times the 2. That will give us negative 8x. Okay, what is 3 squared? 9. And then e to the negative 8x. Negative exponents move the exponent, or move that term to the bottom. So it's e to the 8x on the bottom. I would like you to pause the video and try numbers 4, 5, and 6 on your own. Okay, number 4, 2 to the third, e to the negative 15x. So you have 8 on top and e to the 15x on the bottom. Number 5, you're adding 2 and 4 to get 6, and then adding a negative 3 to bring it down to 3. Number 6, you've got the fraction 8/6. 8/6 simplifies to 4/3. So we know we're going to have 4 on top, we're going to have 3 on the bottom. E to the 2x divided by e to the third, you would subtract. But can you actually combine 2x and a negative 3? So you would write e to the 2x minus 3. It can be written like this with e on the top, or it can be written as 4/3 times e to the 2x minus 3. Either of those would be considered correct the same. Okay, get out your calculators because we're going to learn how to plug this in. Pi is on your calculators. E is also on your calculator. On a typical scientific calculator, like the one we use, the TI-30X2S, it is above the LN button. Basically, on any calculator, E is going to be above the LN button. On this calculator, the LN button is 2 buttons down from the second button on the top left. On the graphing calculator, if you're using that on your computer, the LN button is 2 buttons up on the left from the on button. So to enter e squared in your calculator, you're going to punch in second, and then your LN button, and then 2, close your parentheses, and then push equals. So e squared, e to the second, is 7.389. Why don't you try e to the negative 0.06, see if you can get that answer correct. On your calculator screen, it should look like e and then the little caret. It gives you the parentheses. You type in the negative 0.06, you close your parentheses, and then it'll give you the answer. So it gives you the parentheses when you type in that e key. All right, if we use e, because e is really like the parentheses from the compound interest, we can use e in exponential growth and decay formulas. Yesterday we said that if we were looking at an equation like this, the thing being raised to the exponent determined if it was growth or decay. If that number was bigger than 1, it was growth. If it was smaller than 1, it was decay. Well, e is 2.72, so e is always going to be growth unless the exponent is negative. So if this has a positive exponent, it is going to represent exponential growth. If it has a negative exponent, it's going to be exponential decay. So in numbers 9 through 11, we need to decide if this equation represents growth or decay. Take a look at number 9, e to the 2x. Positive 2x, growth or decay? Growth. Number 10, decay because it's got a negative exponent. And number 11, decay. So you're hoping for like 10 of these on the test, right? For easy points? Okay. So here's our next formula, the continuously compounded interest formula. Many math people call this the Pert formula. Can you see why it's called the Pert formula? Because it literally says Pert. Okay, so P is still the principal, that's the starting amount. R is still your rate, written as a decimal. T is still the time in years. This formula is used when you see the word continuously. So if it says that the interest is compounded continuously, you're going to use this formula. Here's what typically happens if people forget about this formula. They read this: you deposit $1,000 in an account that pays 8% annual interest, compounded continuously. You see the word compounded, so you think the compound interest formula, and you look at the word continuously and you're like, shoot, what n value would you use for continuously? If it's monthly, you use an n value of 12. If it's weekly, you use an n value of 52. If you can't figure out what n value you should use because what number is big enough to mean continuously, that's your clue that you need to use e. So when you see the word continuously, that means you use the Pert formula. So we deposit $1,000. Our starting amount is $1,000. E. What is 8% written as a decimal? 0.08. So raised to the 0.08 times our amount of time. In this case, it's 1. When you plug this into your calculator, you're going to type in 1,000, and then your second, your ln button, and then the 0.08 times whatever. You don't really need to do times 1, but, you know, in case it wasn't 1. Close your parentheses, because when you push second ln, it gives you the opening parentheses, so you have to put in the closing parentheses. If you plugged this in correctly, 1,000 e to the 0.08 times 1, you should get $1,083.29. $1,083.29. pause the videos, try 13B on your own. Same problem, $1,000, 8% annual interest, but this time 5 years. On your calculator screen, it should look like 1,000 E, and then this little caret, parentheses, 0.08 times 5. Close your parentheses, and you should get $1,491.82. Your assignment is worksheet number 2, the natural base. The first chunk of the worksheet is using E, like simplifying expressions with E. Is it growth or decay? The second half of the worksheet, you're using the formulas. Keep in mind you are not going to always use the Pert formula. There is at least one problem that's going to ask you to go back to yesterday and use a previous formula.